In Unit 1, Lesson 2, we're going to talk about how to multiply exponents with the same base. Now, the first thing I want to remind you is that this only works when we are multiplying exponents, not adding, subtracting, or dividing. Multiplying exponents. And they have to have the same base. So we can multiply 3 to the fourth times 3 to the second, but that doesn't work if we have 2 to the second times 4 to the third. That we can't multiply this way. So what we're going to do, actually, is take a look at what it means to multiply these two exponents. So what is 3 to the fourth in factor form? Well, that would look like this. 3 times 3 times 3 times 3. That's 3 to the fourth. Now, we would be multiplying that by, so I'll use this multiplication symbol, times 3 to the second. So 3 times 3. If we were to write that out all as a single multiplication problem, we would be able to write it out like this. 3 times 3 times 3 times 3 times 3 times 3. Now, if we write that out in exponent form, we'll know that that is 3 to the 1, 2, 3, 4, 5, 6 power. 3 to the sixth power. And at this point, I want to show you a relationship. We now have this being 3 to the sixth power right here. 3 to the sixth power. Well, what happens if I were to look at the exponents? This is 3 to the fourth. And this is 3 to the second. If I were to add those two numbers, what would I get? I would get 6. 4 plus 2 is 6. So 3 to the fourth plus the second is equal to 3 to the sixth. And that is our rule for multiplying exponents with the same base. We simply add the exponents. 3 to the fourth plus the second is equal to 3 to the sixth. Pretty sensible, right? Pretty easy stuff. So let's take a look at another one. Down here, we have some coefficients in front of our variables. Now, if I was to write this out, right, I could write this out as 2 times a squared times 4 times a squared. Then, because of the commutative property, I could rearrange these. It's all multiplication, and multiplication is commutative. I can take the 2, right, so I can take the 2 here, and I can take the 4, and I can multiply those together. Right? I can associate those using the associative property. And then I can multiply that by a to the second power times a to the second power. Now you notice that I have the same base. Well, this is easy to multiply. 2 times 4 is 8. And these two are easy to multiply. All I have to do is what? Add the exponents. So a to the second times a to the second is 8 times a to the 2 plus 2. Or 8 times a to the fourth. And I can write that simply by combining my coefficient with my variable as 8a to the fourth. Pretty simple. Let's do one more for practice. Here we have 4x to the third times x to the second. I have a coefficient of 4 times x to the third multiplied by x to the second. So again, I'm going to break these down. I remember this is multiplication, so 4 times x to the third times x to the second. Then I can notice that these two are the same base, and I can use the associative property to group those together in parentheses, just like that. So that what I'm left with is 4 times x to the third times x to the second. And so I'm going to multiply these two, and they have the same base. So I'll just add their exponents together. That leaves me with 4 times x to the third plus 2, which ends with 4 times x to the fifth, or 4x to the fifth. Now this is the simplest way to write it, and that's the way you're going to want to write it, because there's no real need to leave that little dot in there if we can write it simply and mean the same thing. 4x to the fifth is the simplest version of our answer.